This is part 2 of Nutrition 230, Chapter 6, Protein. Protein's functions are the following. Proteins act as enzymes to speed up metabolic reactions. Transport proteins can move substances in and out of cells. Antibodies will help the immune system in fighting off foreign bodies. Contractile proteins help the muscles to move, such as actin and myosin. Hormones are chemical messengers, such as insulin and glucagon, and proteins also help to regulate fluid balance and acid-base balance. Protein deficiency can come in two different forms. Protein energy malnutrition is a term that covers a range of protein deficiency conditions. This can include only protein deficiency or protein deficiency plus energy deficiency. Kwashiorkor is pure protein deficiency, and marasmus is an energy and protein deficiency. Kwashiorkor, seen in this child from Haiti, is characterized by a swollen belly. This type of deficiency typically happens when a mother has two children consecutively, when the first child is not quite done breastfeeding yet. So, thus, the first child is weaned off of breast milk a little too early and typically fed cereal. Because grains lack an amino acid, that child may be getting enough nutrition in terms of energy, but is lacking in protein. Marasmus, as seen in this Somalian boy, is characterized by a depletion of fat stores and wasting of muscle. This is overall malnutrition, so protein is deficient and overall energy is deficient. This could happen in places where there isn't enough access to food overall. Protein excess could also be an issue. Elevated protein intakes over the AMDR, which is 35% of total calories, over long periods of time can result in hydration and kidney function issues, especially in those who have risk of kidney issues, bone health issues, kidney stones, and increased risk of heart disease and cancer. There are also certain proteins that can harm individuals. PKU, or phenylketonuria, is an inherited condition attributed to a defective gene. Aspartame, which is a sugar substitute found in diet sodas, light yogurts, sugar-free bars, and things like that, contains phenylalanine. So in normal phenylalanine metabolism, phenylalanine can be turned into tyrosine. However, people with PKU have that reaction blocked, which creates phenylketones, which are very toxic to the brain, and if they're consumed in excess, could lead to death. Thus, you'll see that foods that contain aspartame have a warning label that says if you have PKU, you should be aware that this product contains aspartame. In addition, MSG, or monosodium glutamate, can cause adverse reactions in some people. MSG is an amino acid called glutamic acid, or glutamate, that's bound to sodium. Anecdotal reactions include a flushed face or red face, tingling or burning sensations, headache, rapid heartbeat, chest pain, and general weakness. MSG symptom is complex, and it's commonly termed Chinese restaurant syndrome because MSG traditionally is added to a lot of Chinese foods. Since MSG awareness has increased, however, many Chinese restaurants have taken MSG out of their products. When we look at nitrogen balance really indicates how much protein you're taking in versus how much protein you're excreting. Remember, when we talked about nitrogen output, we talked about proteins or amino acids being deaminated. And once they're deaminated, or the amino group is taken off, the nitrogen is turned into ammonia, which is then converted to urea, which is then excreted through the urine. If nitrogen intake is equal to nitrogen output, this means that the total protein that you're consuming is equal to the total amount of nitrogen you're excreting. Healthy adults who consume adequate amounts of protein and maintain body weight are considered in nitrogen balance. On the other hand, you don't really want to be in negative nitrogen balance. This would mean that your nitrogen intake is less than output. This often occurs due to injury and illness. It can also happen if the diet's too low in protein, such as in kwashiorkor, or protein and energy, such as marasmus. In the US, we would tend to see this in an extreme fad diet, such as a juice fast or something like that. Then, in certain times of life, we're in positive nitrogen balance. This means that nitrogen intake is greater than nitrogen output. Total body protein increases in these circumstances. This happens during growth, through childhood. It also happens during pregnancy, and it could be a goal of people who are increasing muscle mass by lifting weights as well. When we look at protein requirements, they're actually much less than many people think. Adults require 0.8 grams per kilogram of body weight for protein. Remember, 1 kilogram is 2.2 pounds. So for a roughly 60 kilogram person, that would mean they'd only need about 54 to 56 grams of protein each day in order to meet the needs. The AMDR, however, is a pretty wide range. The AMDR is 10 to 35% of energy for adults. Protein needs will increase during certain periods as well, such as during growth, pregnancy, and lactation. You can use the exchange lists, as we talked about, these lists that are developed by the American Dietetic Association and American Diabetes Association, in order to calculate your protein requirements. As you can see here, the starch group has about 3 grams of protein, fruit has 0, milk groups tend to have 8 grams of protein, unless you're looking at Greek yogurt, which is around twice that much per serving. Vegetables tend to have about 2 grams of protein, meats have about 7 grams of protein, and the fat group has 0. Now, it's controversial on whether or not we really need protein supplements. Protein supplementation in pure protein form, such as through a high-quality whey protein, a vegan source of complementary proteins, such as pea flour and cranberry protein extracts, for example, or egg white protein or casein protein, could be used post-workout when an athlete's trying to get in some very quick protein that's easily digestible and absorbable. However, for the typical person, these are very expensive and haven't really been proven to be any more beneficial than food. In addition, as we talked about in our digestion and absorption portion, you don't want to take only individual amino acids because they can really fight for transport in terms of getting into the body. So the intake of excessive one type of amino acid could end up limiting the absorption of another. Protein quality really varies depending on the food as well. So as you can see here, peanuts, lentils, oats, and wheat have a much lower protein quality than something like beef, egg whites, casein, and kind of a different one, isolated soy protein. So as you can see here, most of the really high quality protein sources are from animal sources, but soy protein also is quite a high source of protein in terms of quality. There are a number of different ways that we can measure protein quality. There's the chemical or amino acid score. In this one, you can calculate it by dividing the milligrams of a limiting amino acid per gram of test protein divided by the milligrams of limiting amino acid per gram of reference protein. And the lowest amino acid ratio is calculated as the chemical score. You can also use a protein digestibility amino acid score, or PCD-AAS. This is the amino acid score times digestibility factor, so that would take into account anything that would prevent digestion and absorption, such as fibers, etc. Protein efficiency ratio, or PER, is weight gain when fed a test protein divided by weight gain when fed a reference protein. This is typically used in lab animals. There's also net protein utilization, or NPU. This divides the nitrogen retained divided by the nitrogen consumed. And this is a measure determined by usually a radioactive isotope that's examining, how much you consume versus how much that you retain. That's how they would be able to measure that. And then the biological value is a measure of protein quality determined by comparing the amount of nitrogen retained with the amount absorbed. So this takes into account the digestibility. Again, it's just looking at absorption versus retention rather than consumption. Because remember, some of that protein will be eliminated in the feces. So the biological value will take away that factor of any of the nitrogen contained in the feces. Protein complementation means that we can add two different types of foods together in order to create a complete high-quality protein. Rice, as well as other grains and corn, are very low in the amino acid lysine. Beans, on the other hand, are quite high in lysine, but very low in methionine and cysteine. Therefore, if you add a grain to a legume, such as in rice and beans, you can create a complete protein or high-quality protein using two foods instead of one. In order to choose proteins wisely, we want to make sure that we're having a variety of proteins in our diet. Leaner cuts of meat-type proteins and milk-type proteins will help to prevent heart disease. In addition, we'll have some heart-healthy omega-3 fatty acids by making sure to have some nuts and seeds, as well as some fish. We can also couple our protein with other important components such as zinc and iron by making sure we have some animal sources and have some healthy monounsaturated fats and fiber by making sure we have some plant sources. A number of people choose to go on a vegetarian type diet for a variety of reasons. There are a number of types of vegetarianisms or levels of vegetarianism, and these go from the least restrictive to most restrictive. A semi-vegetarian excludes red meat, but may include fish and poultry, as well as dairy products and eggs. A pescatarian excludes all chicken and turkey, as well as red meat, but does include fish. Some pescatarians choose not to consume eggs and milk, and others do consume eggs and milk. A lacto-ovo vegetarian excludes all animal flesh, but does have eggs and dairy products like milk and cheese. Lacto-vegetarians exclude all animal flesh and eggs, but do include dairy products. An ovo-vegetarian would be the opposite. An ovo-vegetarian, not listed here, would include eggs but not dairy products. And then vegans exclude all food of animal origin. Some people function really well on vegetarian type diets, and other people do struggle with deficiencies. It's important to work with a doctor and possibly a registered dietitian if you do choose to go vegetarian in order to help you navigate what the best choices are for you. There are a variety of ways we can complement our proteins and include soy products if they agree with us in order to meet protein needs with a vegan diet. Remember, some of the vitamins and minerals in a vegan diet are a little bit less absorbable, so those are really more of the concern. By making sure we complement grains with a bean or a legume, or have some tofu or other soy products in our diet, we can really make sure that we meet protein needs. However, B12, calcium, vitamin D, iron, zinc, iodine, and omega-3 fatty acids must be carefully put into the diet either through supplementation or through foods rich in those different types of vitamins and minerals. This is the end of the protein lecture. Make sure you go back into Wiley Plus and answer any questions, read through the protein chapter a little bit further, and make sure you review protein synthesis and metabolism. We've finished up with our macronutrients at this point, so it's really important for us to make sure that we understand all the different ways that protein and carbs and fat can go through the citric acid cycle, electron transport chain, and create ATP, or can go to storage.